Yeah, this project is only going to be used to demonstrate and have you guys do a little bit of work with loops. And loops are, not only are they really powerful as far as the things you can do with them, but they're really, really common. Like, loops are probably one of the most common things I write when I'm doing game development, because so often do you need to do things over multiple objects. And the thing about loops, it's a way to like create a portion of your script that can repeat any number of times that you want. So let's say you make some part of your script that does something really cool, and you want to do that again multiple times. Well, loops are a way to repeat that behavior as many times as you want. Let me turn down the volume here. So there are a lot of different kinds of loops that you can work with. I'm going to show you guys just one, which is like the most common one that we're going to use, which is the for loop. And there's a variant of that which is called the for each loop. And they're both basically the same thing, but those are the only two that we're going to use in this class. There are other types of loops called while loops, which are useful in their own right, but in any case that you could use a while loop, you can use a for loop instead. So I want you guys just to work in a level blueprint today. We're going to basically be working with binding things in keys. And all I want to do for now is just, I want to bind the F key to print out a string to the screen. So I'll just take the F key here, and I'm just going to have it print a string. This is nothing new. This is just, I'm just going to have it print out a string. So now I press F in the top left corner, and I'll see hello. I just want to prove that that works just as a first step before I dive into anything else, so that I can make sure that my key binding is working correctly. So if I asked you to say, as a kind of a contrived example, I want you to print out all the numbers from 1 to 100 to the screen in incrementing order. The only way that you knew up to now to do that would be to literally put 100 of these in a row, right? Like you could print 1 and then 2 and so on and so forth up to 100. But that seems really, I mean, it should seem obvious that that's kind of like the wrong way to do something like that. You may not ever have a need to show like 100 things in a row, but a good example of this is like, let's say you're like searching through your inventory, right? World of Warcraft has the ability to find items in your inventory based on some string that you type. Or let's say you're, let's say you want to you're in Diablo 3 and you want to disenchant all the items in your inventory that are rare or that are magical. There's a button for that that basically goes through your inventory, finds all the items that match a certain set of criteria, and then disenchants them. In those cases, you're still using loops. And a lot of times you don't even know how many times you need to loop either. That number of times that you need to loop is dependent upon what information you have at that time, right? So in Skyrim, let's say there's a button that just dropped all of your inventory to the ground, right? Every single piece of inventory that you had to the ground. How many inventory items would you need to drop? That changes, right? You might have nothing in your inventory that you need to drop. You may have 1,000 things in your inventory you need to drop. That number changes based on gameplay. So let's first start with some really simple examples here. Okay. So I want to print the numbers from 1 to 100, and I want to have them automatically kind of be generated based on using a loop. So if I drag a wire from the F key, and I'm going to type for loop, and I'm going to use, that's two different words. And so we're going to go over the for loop and the for each loop. And I'll talk about the for loop with break, but we're not really going to use that today. We're just going to add a simple for loop for now. And a for loop is actually, it's pretty simple on the surface. It has 2 variable inputs and then a bunch of outputs, which I'll talk about. So when you're talking about loop, usually you figure out where you want to start and where you want to end. And even if you don't necessarily know where you want to end, when you're passing like at that time, for a for loop, you have to kind of tell it how many things you want to know. In the case of things like like an inventory where you don't necessarily know, you just want to go over everything, we're going to use a for each loop for that. So we'll put that on hold. We're just going to use a really simple example for now. So the first index here is where the loop is going to start, and then the last index is where the loop is going to end. And then it's going to increment by 1 every time that the loop iterates, and then spit out 1 execution wire every time it adds 1. So let's just start with the inputs here. So I want to go from 1 to 100, right? I want to count the numbers. I want to just print out the numbers from 1 to 100. So this is going to start at 1 and then add 1 to it until it reaches 100, and then it's going to finish. So on the right side here, this is kind of like any other blueprint function, only it has 2 sets of execution wires. This guy here, this execution wire will fire every time it executes a new iteration of the loop. So this guy will execute 100 times. Okay? This guy here executes when the entire loop is done, after all 100 iterations have completed. So this guy will fire once. Every time this guy fires the loop body, this variable represents what number we're currently on. Okay? So what we can do is we can hook up into 2 different execution outputs. We can either do something every time the loop iterates, or we can do something once the loop is completely finished. Okay? So let's just print out a string during the loop body here. And all I want you to do is just drag the index into the string. We'll just print out what the index is at the time that the loop iterates. Yeah.
How did you make it blue?
Oh, you're running right now. And then when you play it and you hit F, you should see the numbers. They kind of go off screen because it counts out and prints them all out at the same time.
Why does it stop at 67?
No, you got it. It actually prints from bottom up, so all the other numbers are below it. So it actually printed 1 through 66 already, but there's not enough room on screen.
Gotcha.
Each new one comes up on top of the other one. So let me know when you guys have that too. Try different numbers in here too. Try printing up to like, see what happens when you put it up to like 10,000 or 100,000 and you press the F key. You should notice like the game actually stops until it iterates through all of them. If you put in something like 100 million, it will probably lock up your editor for a minute or so.
It takes a while, but it does work for 100,000.
Okay. So as an exercise, why don't we do something like,
Infinite loop.
oh, how many did you add?
1,000,000.
Okay, so I guess 1,000,000 is the limit. So why don't we do something with this loop? We can do some work. We don't have to just print out things. We can, let's just start off simple, right? Let's go from 1 to 10. Okay, so that's the loop. It prints out the numbers from 1 to 10. Let's just add up all the numbers from 1 to 10. So can anyone tell me what, there's a formula for that you can use. What's the actual result of 1 plus 2 plus 3 plus 4 plus 5? You can do this. 1 plus 2 plus 3 plus 4. 55. It's like, what is it? This squared divided by 2 plus half of the result I think. There's some formula for calculating the sum of that. But we can actually. You saw a TV show? It's not really like a super. I've never used that. I've never had a need to like figure that out. But let's say you want to add up all the HP. Let's say you're looping over all the enemies in a level, and you want to get like. Let's say you have a boss, right? You're fighting a boss in Skyrim, and he has like a right arm and a left arm, and a right leg and a left leg, and they're all attackable. And each of those pieces of his body have different hit points. So let's say you want to represent the boss's HP as a sum of all of his body parts. Let's say the boss we're fighting has 10 different parts. We can add them all up. So what we can do here is we can add up all the values, and then when it's done, we can just tell you what the result is. So I'm going to make a new variable for that because we need to basically keep track of the sum of all the numbers. So I'm going to make a new variable called sum, and you guys can follow along with this. I'm going to change it to be an integer type since that's what we're working with inside the loop. Kim, are we ever going to get double monitors back in here again? Because like it's.
That's a pizza with the fries thing, guys. Okay?
Yeah, because like
My papers,
it used to have double monitors, but like. Because like
we're not fat. The other rooms that still have them aren't fast enough for you, are they? 202 or 204?
I don't know. I never run Unreal on them. They might be fine. So.
Are you running Unreal 4?
Yeah, this is Unreal 4.
Is it in this room?
Yes. No, it's not in this room. Everyone has to bring it in from home.
Everyone brought it in. Okay.
Yeah.
Why is it that I have to pay for it if it's free?
No, you don't have to pay for it. You shouldn't have to pay for it.
That's what I told the president
Yeah,
last week. 'Cause
there's.
Travis is having trouble in his level design class.
Yeah.
And they upgraded to the new one, but there wasn't enough RAM in the computers.
In his lab.
That's correct.
Yeah, the Epic has a partnership program, so with schools that they will offer to you for free, or I think it's a cost of one $19 a month license and you can distribute it to as many computers as you want, and so everyone is on the same image of that build of Unreal.
So we could have it in here and in 260.
Exactly. They let you image it to as many computers as part of the academic program as you want. So it can be part of this entire school.
Okay.
For now, though, like you can sign up as a student for free through GitHub. So GitHub has a student education pack, which lets you get it for free, which you guys should have already signed up for. I just got my email like 2 weeks ago.
I'm still waiting on the email.
Did you say GitHub?
Yeah, I'll show you the link to it. So if you go to GitHub, if you Google GitHub Student Pack,
Okay.
there's this GitHub Student Developer Pack.
Okay, got it.
And then as part of the Student Developer Pack, when you enroll, at the very bottom, you get a copy of Unreal,
Okay, right.
which is normally $19 a
Well,
month.
see, and this is what I need because I went back to, because Travis told me it was free, so I went back to the president and said, why are we worried about buying it when we could put it 264 and 257 free?
Well, so that program, the GitHub program, is for individual students, for
But
stools.
Travis told me about the partnership with it.
Yes,
So
yeah.
Epic has a,
Yeah, they have a partnership where you can, the education program here,
right. Okay, got it.
Unreal Free is not free to use for colleges and universities, and
Okay.
all school-owned personal
Okay.
copies.
And that's Epic, UnrealEngine.com education.
Yeah.
Thank you.
Mhm.
Travis gave me bits. He didn't send, Travis is good about talking to me, but he doesn't always send me.
Yeah, what's nice is that you can actually make games and you can sell them if you like. We would still own the rights to that game.
Really?
Epic just gets 5% of the royalty of any profits that are made, but I don't think that's for getting a free commercial engine. I think that's worthwhile.
That's incredible. Thank you.
Yeah. Okay, so sum, right? So remember, was it last week that we did the arithmetic? Or was it 2 weeks ago? Last week, right? We talked about, yeah, it was a ton of fun. We talked about taking variables and modifying them, right? So if I want to add 1 to the sum, right, how would I do that? I have this sum variable. How would I add 1 to the sum again? Do you guys remember that? Someone give me an answer. So let's...
You set and then you drag out and then do a plus.
do this guy and then do a plus, right? And then put that into here. So I could put 1 here. So this adds 1 every time, right? So what if I want to add something other than 1, like say the index? What would I do? I'm going to put this right here. I'm going to plug that in right there. What do I do if I want to add the index into this? That's it. And then if I want to print it out after it's all done adding, what I can do now is use the completed wire. So this guy fires 1 time after the loop has completely finished, which means I can print the string, and I can take my sum, I can just plug that in, and now when I play and press F, I get 55 as the answer. What's nice is that this will work for anything, right? Like, what is the sum of 1 to 100? 5,050, okay. 1 to 500? Okay. So it's actually adding up all of the numbers from 1 to 500 and then sticking them into this variable here. Yeah, what's up?
What is the add pin for the add integers?
If you want to add more than 1 integer, so you can type in numbers here, it'll add those on top. It's just basically adding more things to add every time this thing executes.
Okay.
So it'll add sum plus the index plus 1 plus 3 plus 5 plus 124 plus 42, however many you want to add. This is if you have a lot of things going into the same add. Like if there's something, like let's say I wanted to add 1 on top of everything else, then you could do that here. Or if you had other variables that you want to add.
Like stat total?
Yeah. So yeah, we can do that.
Okay.
I'm going to remove all these. So that's like the simple premise of a loop, where you can work over some range of numbers to do some meaningful work. In this case, our meaningful work isn't really specific to games. I don't really know of a case where you'd want to do this in a game. I can't really think of an example where you'd want to do this specifically. But this is kind of a contrived example. Normally, you're not using the index as you're not really using this as something that's involved in a calculation. Typically, what you're doing is you're looping over pieces of work, like how many inventory items you have, or how many enemies are in the blast radius of a bomb. And then you're taking this index and you're using it to grab each specific enemy that's in some list somewhere. Okay. So I want to talk about arrays now that I've talked about loops. Because arrays and loops are like best buds. Those guys go everywhere together. They play Halo together. They go drinking. Those guys are like total comrades. And having one without the other is kind of rare, actually. Normally, I would say most of the time when you're working with loops, you have an array right next to it. And I kind of went over arrays already a few weeks ago. I talked about arrays. Arrays are just lists of things. And you can make an array out of any variable that you have in your blueprint. So there's a couple things about arrays that you have to keep in mind. First, if you have an array, all the elements in that array have to be the same type. So if you want an array of integers, that's all it can store. It can only store integers. You can't mix strings in there. You can't mix floats in there. You can't mix bools in there. It's just an array of integers. It all is the same type. And it really is just a single variable that has a list of info inside of it. I'm just going to show you guys just a refresher course here. I'm going to make an array of spells. No, this part I'm not going to have you guys do, but I will have you guys join in just a second. I will tell you. Okay, so I'm going to make an array of spells that is just first a string. And then if you want to make something an array, up to this point we've just made variables and they were a single type and you could drag them in and you can get them and you can do fun things with them. If you want to make something an array, you can just click this little box next here, which will turn that variable into an array of that type. So by clicking on it, that's it. Now it's an array. I compile. Now I have an array of strings. And if you look here in the bottom left, the default value changed. It used to look like this, where it was a single value like fireball. But now, if I change it to be an array and compile, I can now have this button that lets me add any number of spells that I want. So I can have things like fireball or poison cloud, or like lightning bolt. Right.
Ultima, that sounds cool.
Ultima's from Final Fantasy. It's like from Final Fantasy 6 and on. It's pretty much the highest level spell in the game.
It sounds like it.
That's what they called it that, yeah. So this variable now actually holds 5 other variables inside of it. It's a list. So why would you do that instead of just making 5 variables, each one its own name? The specific reason is that you really often want to have one place which stores everything, and then you want to use a loop that works over them. If you had these spells all as 5 individual variables here, you couldn't use a loop to work on them. Let's just say I wanted this loop to print out all of my spells, right? I could do that because this is an array. If they were individual things, there's no way I could actually go and retrieve each spell. And the reason is because an array is both a list, but it also has an index which gives each of my spells a unique identifier for where that spell lives. So Fireball is my 0th spell, and Poison Cloud is my first spell. Remember, they start counting from 0. Ultima is my spell at index 2. Frostbolt is my spell at index 3.
So it's almost like a folder instead of like a document.
Yeah, that's a good way to think about it. It's like a Windows File Explorer where you have a folder which has multiple things in it. So I'm just going to delete all this for now. I don't really need the sum or anything anymore. What I just want to do is I want to just print out Frostbolt to the screen by getting it out of the array. So there are blueprint functions that let you get items out of an array, but you have to tell it what index you want to get it. All you say is, hey, array, can you give me back what you're currently holding at this index? And it'll spit you out one of these things. So if I wanted to get out Frostbolt, what would I pass? What index is that at? 3, right? So if I want to print a string, again, and this time I want to print out Frostbolt, well, it's very similar to how you print out anything else. So I'm going to drag spells into here, and it's just the same. It has the 2 same things, get or set, and it has this. Only I can't plug this guy into here anymore. Because what would that actually mean? If I were to plug this thing in here, it doesn't know which spell I'm trying to print out. That's why it's not letting me do that. It says an array of strings is not compatible with string. So you have to pluck out one single item out of that spell list, right? And the way you pluck out those things is you drag a wire from your array and you type get. And get does exactly what you think it does. It gets a single item out of the array and you tell it what index you want, right? So for Frostbolt, what index do I need to type in here? 3. And then I print that into here. Now if I compile and play and I hit F, I get Frostbolt. That's basically WoW in a nutshell. If I was to put 1 in here, what would I get?
Fireball. No.
Can you see that? Poison Cloud? Okay. Cool. Now that's neat where I can type in an individual number, but what's even neater is that I can actually use an array to print out all the spells in that list. So there's 2 ways that you can do this. I'm going to first show you how to do it using a for loop, and then I'm going to show you how to do it using a for each loop, and then I'll show you why for each loop is usually going to be way easier in a lot of cases. So let's do another example here. Right, so we're going to make another for loop for this. So as I did before, I'm going to drag a wire. I'm going to do a for loop. So what is my first index going to be if I want to print out all the spells here? 0. What is my last index going to be?
4.
4. Cool. And then I could plug this in here. And what do you guys think? I could just plug this guy into here, right? Seems reasonable to me.
Yeah.
So that for loop is going to go over this 5 times total, because how many spells do I have? 5, right? And it's going to print out each one. And there they all are. Each one of my spells in that list. What's that?
In reverse order.
Yeah. It's actually improper. You count from the bottom up. Because the first string it prints is on the bottom, and then the next one goes on top. It pushes the rest of them down, so it's actually in the right order. It just doesn't seem like it.
Ultima's in the same spot no matter what.
Yeah, that's true. So here's the thing, though, is that what if I add a bunch of spells? Let's just say I add a bunch more spells. Like I'm gonna pull my Chrono Trigger knowledge here out. Let's just do for those of you guys. So if I want to print out this now, what do I have to do? This one needs to be 7, right? Cool, that works. But what if I don't want to have to update this every time? Like, what happens if I don't know how many spells? Like, let's say I'm playing the game, right? And I level up and I learn a new spell. I can't go in there and change this number by hand every time that you gain a level. The game's already running. This number that I typed in will never be anything other than 7, right? So how do I actually get the correct number to put in based on the size of the array? So this guy here, this array has another function you can call on it that gets you how many elements are in that array, which is super helpful because that's what we can plug in right here. So I can type here and I can do length. And this will return me how many elements are in this list. There's a little bit of a problem, though, because this guy here, he is actually going to give me 8, right? If I plug this guy in here, notice there's actually a blank spot in the top. I guess you can't really tell. So it's actually returning me 8, because that's how many spells I have. But remember, what do we actually want to put in here as the last index? It asks for 7, right? So what we actually need to do is we need to pass in this length minus a 1 into here. Okay? We need to subtract 1 from it because even though I have 8 total spells, the index only goes up to 7 because we start at 0. So all I have to do is take this length. I'm going to subtract 1 from it and then plug it into here. That's it.
Why is it trying to make 8?
So how many elements, how many spells do I have total?
7. Oh no, there's 8.
There are 8 spells, yeah, because it starts at 0, yeah. You'll get used to it. It starts counting at 0. Being 0 index is just a part of learning how to use blueprints.
For length,
It returns 8. This guy returns 8.
returns the length, not the index.
Yeah. So remember what we typed in here, right? We typed in 0 and 7, right? It starts at 0, goes up to 7. This guy is returning the number of spells I have, which is 8.
Oh, okay,
So this guy's returning 8. I need 7 instead. Like if I go here, let's just remove, I'm just going to trash everything. Okay, I'm just going to have 1 spell. What is this guy going to return? 1, right? What does this guy need to be in this case? 0.
oh, okay, I see now.
If I have 2 spells in here, this guy is going to return 2. This guy needs to be 1, right? This guy's always going to be 1 less than what this guy returns. I need to get 1 less than the value that the length returns, which is why I need to subtract 1 from it. Because we start counting from 0 in this case, but this guy starts counting from 1 instead.
So this is counting the actual number of things, that's counting like the names of things.
Exactly, yeah. This is counting the actual number of things. So I actually have 2 spells in this case, right? Okay.
Who figures that out?
Why do they start counting from 0? There's a very good Stack Overflow question on why everything is indexed from 0. Mostly it has to do with the fact that in computer science, in the computer, it represents the very first number that it has is 0. And so it's actually a space savings. You can represent more numbers that way. It's actually a huge, if you ever want to look it up, go Stack Overflow y indexed 0. Y or 0 based array is the norm. Wait, here. There's a huge article. There's explaining why everything is. There was a discussion at one point about indexing from 1. There are some languages that do index from 1, but the standard, 99% of them, index from 0. So, yeah. OK. So I'm going to have you guys do a little bit of work. I want you guys to create an array of 10 numbers. Just create a variable that is an int variable that is an array. And I want you to just add 10 random numbers between 1 to 100. Then once you have that, I want you to print all those numbers to the screen. And then once you have that, I'm going to have you guys do some work. I'm going to have you guys figure out whether those numbers meet some certain criteria, which I'm going to give you. Like, print it out only if that number is greater than some other number, or only if that number is less than some other number. So I just want you to create a variable that is an integer array, and just plug in 10 numbers here.
Any number?
Yeah, 10 numbers here, any numbers from 1 to 100. And I want you to just print them out to the screen using what we just did here. Imagine these are like the HPs of the enemies that are currently in the AoE of an attack that you just did. Make sure that you click this button here. That turns it into an array, because otherwise it's just a regular old number. Okay.
I'm not sure it's going to be a full class. Are you at all interested in what we do as a directed study? So you're here for 2 hours, and then you examine the stuff after leave.
Sure.
Are you okay with that?
Yeah, I mean, is anyone else?
I have to take the
You
same
have to
class.
take it too.
Yeah.
So you know, I usually get a chance to talk to instructors, but you know, Saturday I've been gone, just you know that.
That's fine. Yeah, so would that's just 2 hours on Saturdays at the same time, like
It's up
starting
to
at
you.
8?
You tell me. Do you want to be here at 10? You can be 10 to 12. You can be 8 to 10. It's up to you.
What do you guys want?
What do you guys
8 or
want?
10? What's easier for you?
10 would be easier, but it doesn't really matter.
I
Okay.
mean, you guys will have the classroom booked from 8. So this would be your room. You can come in and do your homework before he gets here. And then
Whatever's
go into
easiest for you.
whatever you want to do.
Since it's going to be a smaller class, my thought was that you guys are actually going to work together anyway.
Okay.
There's a lot of benefits to doing that for Unreal. So why don't we start at 10 for that for
Okay.
advanced, and then we'll do that. Are you taking advanced as well?
You taking advanced game prototyping next quarter? Okay, so the 3 of you.
Okay.
Now, if it goes over a certain number, it becomes a full class.
What is a number?
I think the magic number is 6.
Okay.
Or 5. I think it's 5. I have to check and see.
Because
but-
we have 5 in this class technically, although
Okay.
Michael and Christian aren't here today.
Okay.
So
I guess what you guys, can you find out if they're going to take it? Well, five will
I can
be,
ask them
five
next
will
week.
be a DS.
Oh, the
If we
guys
get a
from the
sixth
class.
person, then it bumps into 4 hours.
Okay.
Okay, because that's the rule, but,
Small class is only 2 hours long?
yeah, if it's a directed study, because
So
there's
it doesn't
just
take as
not
long to teach
enough,
the
yeah, it
people.
doesn't take, well, you're getting hands-on.
Right.
You know, you're getting hands-on with him, so therefore, you're gonna have this lab for the whole 4 hours, but he's only gonna be here for 2 of it.
The problem only is that there's actually enough material to cover 4
I know
hours
that,
of
I know
that.
that.
Like, there's still a ton of stuff to do. So I would almost rather, if you guys are, the only problem is if you guys have classes afterwards, like,
They
I can give you
don't.
guys 2 hours of lecture and let you guys work for another couple hours afterwards, but I don't know if, it seems a little, like, I still could definitely use more of that
I
time.
know that, I know that.
Well,
Well,
I'm
then
coming
get
from
that.
Chino, so 4 hours to me is better than coming up here for 2 hours
I
class.
mean,
Yeah.
well, you need 2 more people. Try to, what we need to do is bump it over the 5, as
Well,
much
if we have
as
the
we
class,
can.
if we have the class, or if we have the lab for 4 hours, he could teach for 4 hours if he wanted to, right?
Yeah, but that's not fair to him.
But if he wanted, oh, because he's not getting paid
It's not,
extra.
Yeah.
yeah, it's not fair to
Gotcha.
him. So, the best thing you could do for me is get
Enlist people.
more people. More people would help because, and I don't know how many are at this level that haven't taken the next,
Mhm.
you know, we just haven't had a chance to do, because I've been gone a lot.
Yeah, this
you
is
know.
the only time since I started teaching here
The
that we've
smallest
ever had.
class,
Yeah.
yeah. I
It's
think
normally
what's
it's been-
happened is we've caught people up,
Mhm.
because Glenn's kind of really strategically trying to plan that, but, if you know of anybody, pass the word, and, you know, just send me an email and say, this person, you know, have them send me an email, student number and what class, and I'll just plug them in, so.
Okay.
It's what I wanna do, because I don't wanna, can I talk to you just 1
Sure.
second out here? Sorry, I'm gonna take them out for 2 seconds, guys.
Once you have that, you guys can add some conditions. Only print out the number if it's greater than 50.
I'm still stuck.
numbers?
Yeah.
Did you by chance get to print them out?
I got the numbers to print, and then I was trying to get it to print the numbers that are less than 50. I thought this would be the way to do it, but it's not.
That is almost there. This is returning true or false.
Yeah.
That's all it's returning. So you need to plug that into something else that is, hey, use that true or false to spit out one of two execution layers. So use a branch in that case.
In here?
Yeah, you want to plug in a branch in there. So now this guy will say, hey, is that true? Do this. If it's false, do this.
Okay.
So if it's true, you want to print out the string. Yeah, put the white execution layer. But, and for false, you don't need to do anything.
Just use it.
Yeah, because you're not going to print anything that's false, but you do need to plug this guy in here. This guy needs to be in between these two. And then what are you printing here? What string are you going to print here? This is it's empty right now.
It should print the numbers.
Yeah, it should print the number. So which one of these things is the number that you're getting?
Here.
Yeah, so that's a bool. You are getting, it's that guy right there, actually, that's the number in that list, right? So that's what you want to print. You want to print that guy.
So that's telling it to print. This says print a number. This says if it's less than 50.
Yeah, so let's just walk through this a little bit. Can you pull these two guys up? Can you pull this branch up to here? That's gonna make a little bit more sense. So let's just step through one at a time, like from left to right. So you hit F. This loop is gonna run a bunch of times, right? So it's gonna go over every item in your list of numbers. And then every time it does this, it spits out one of these every time, right?
Right.
So for each one of the numbers. So the first time it goes through, the first number it's gonna get is what? What is your first number in your list? 1, okay? So it's gonna go here, it's gonna fire this branch. This branch is gonna run now. It's gonna be like, cool, which one of these two should I fire? Well, it's gonna go backwards from here, okay? So it's gonna run this, it's gonna be like, cool, I don't know which one I need to fire, I need to look at my conditions. It's gonna go backwards and find out what do I need to test. Oh, you're telling me to compare this number greater than this number here. And this number here is what you plugged in here, right? It's getting the actual value, right? So that, so it's like, cool. If it's true, go ahead and print. What is it printing? It's printing that same number out of that list. This thing is the same. You're both comparing that number and you're printing that number.
Okay.
And then the next time through the loop, it's going to do the same thing. It's going to see, hey, compare a number against 50. What is that number? Well, I'm going to get that index out of this array. So it's basically like almost like going backwards, right? So this guy falls here, says, cool, give me a number. What is that number? Oh, you want me to get an element out of the array, out of this array at this index. So it's kind of weird because you have to go forward and then follow it backwards to see what it's actually
It's
asking
like one
about.
of those survivor challenges where you gotta like go and dig up the key here and then go over here and check to see if it fits and go back over here and
Yeah, it's like you have, you know what you want to do, but you don't know all the pieces to it yet, right? And the pieces are made up of a bunch of things that go on while after you've asked what to do. Okay, so now that should work where it prints it out and it's greater than 50. Cool, those are the only numbers that are greater than 50. Hey, how's it going? Get it out. Oh, cool, nice. Yeah, perfect. Thanks, dude. All right, Joey, what you got? You got printing out too?
Yeah, well, so I thought we just needed to add them all. Oh, and I guess I broke it. But I have that one checking if each one's more or less than 50.
Can you print out the actual number too?
Yeah.
So what kind of
Yeah, that
cases?
is 0.
What kind of cases would this be useful for? Well, let's say you have a. You ever played? I don't. Not everyone here has played WoW, which is interesting. But if you ever played WoW, like Warrior has a move, Execute, that does a lot of damage to people that are less than some threshold of their HP, right? So enemies that are lower than 30% HP get instantly critted and I think killed. So you can imagine if you had a list of enemies and your ability basically had an extra chance to do damage to enemies over 50% health, then this is an example of where you loop over each enemy, look at their health, and if it's greater than 50, do something to them. In this case, we're just printing out a string, but you can imagine it'd be like, oh, maybe I can subtract more health from those guys, right? Or maybe your spell only does damage to people over 50% health.
Maybe you have to be a certain level in order to go into a certain area or do a certain thing.
Yeah, I mean, in those cases, you can. It's the same idea where it's a branch. It's not necessarily an array or a loop in that case. I'm thinking along the lines of combining what you just said with things that have to happen over a lot of different like enemies or inventory items. Like how about sell all the items that I have that are lower than some percent of durability, right? Things that are lower durability, just sell them all, right? So go to the vendor and select sell. Cases like this are also useful for like even in that case where I want to sell items, sell any item that's like lower than some rarity, right? Like in Diablo 3, there's a button you can click to disenchant items that are lower than blue quality or yellow quality. And so you can have a loop that goes over each element. And instead of comparing like 50, you would say, hey, give me your rarity, and if it's less than this value, then go ahead and do something. Yeah. Okay, so I'll show you guys another way to do this same thing, a little bit easier though, because I had to have you guys do it the hard way before I show you the easy way. But I will say it's the easy way is normally what I do. So let me just add a bunch of numbers here, 42, 55, 12. I'm going to show for the recording here how you would do what we just talked about. So there's my spells. And instead of spells here, I'm going to use my number list. I'm just going to print out all the numbers in my list to start. So this is just going to print out all the numbers in that list when I hit F. Cool. You can see the numbers are there. And then if I only want to print out numbers that are greater than 50, in between me doing the loop body and printing out the string, I want to put a condition there. I want to say, hey, don't print out every single one. Print out only if this condition is met. In this case, a condition is going to be that some integer is greater than or equal to 50. And that integer is going to be this value here. I'm trying to like organize it so it's makes sense. It's hard to like keep things clean. And this way, now it'll only print out that value if it's greater than or equal to 50 here. Hit F. Okay. So that's how you do a loop that prints over certain criteria. If you were to do other things like, hey, only print it out if it's less than 50, you would probably know how to do that. Just replace this condition. Only print it out if it's like equal to some number, like if it's equal to 512. Print it out. You could do that too. Does this branch make sense as far as what it actually does? Notice if this thing is ever, what'll happen now if I leave this thing blank and uncheck this box? It'll never print it out, right? Because that thing will be false all the time. So I'm hitting F and nothing happens. If this thing is true, does that? It prints all of them all the time. So if this is true, then it'll never fire this guy, right? Okay, branches are super important. By the way, we're going to be using branches a lot in Angry Birds because that's how we're going to determine whether to break a brick or not, right? So Angry Birds, a brick only breaks when you've hit it with sufficient force. So you're going to have a branch that says, hey, how much force did I hit it with? Is it greater than this number that I type in? If so, go ahead and break it, right? Okay, so back to the easy way of doing this loop. I'm going to delete all of this. And if I want to print out every element in this list, you guys can follow along here. This time I'm going to use a for each. I'm just going to use a for each loop. I'm going to type for each loop, one word. Notice this already looks a little different. If I compare it to the for loop, what is the difference here? Let's see. The for loop has a start and an end index, a first and a last index. The for each loop just has an array you plug in because the for each loop will automatically go over every element in an array and then spit that back out at you and it gives you that element in the array.
So it covers the whole range already.
It already covers the entire range for you. It automatically does that work for you.
So the for loop is like reaching into the filing cabinet to pull out specific things, and the for each loop is like, it's gonna grab the whole filing cabinet.
Yeah, it's like the for loop lets you specify whatever range you want, while the for each loop will always give you the entire range every time. Which this is way more common of a case in almost every case. So if I want to print out all the numbers in my list, I can just drag this guy. To make it even easier, I'm just going to drag this right on top of the array. That's the same as me doing this, like doing a get and then plugging it in. You can do that too. Just keep in mind that dragging it on top of the input is just faster. And then in a loop body, same thing. I just print a string, only now there's one more output variable in this for each loop. It has loop body and array index and completed, just like the for loop. But now it also prints out, it will return for you the current element of the array that you're working on. That's it. And that's the same thing we just did to print out all the elements in the array. No gets of an array are needed, and it'll just print them all out. Okay? This is super useful. Like this guy right here will save you time, because this is kind of the same thing you're going to have to do in almost any case that you're working with arrays. You typically care about all the elements in an array. It's pretty rare that you want to get like a sub-range of an array. Like you don't really ever want to get the first 3 elements or like the last 2 elements. You typically want the entire shebang. You want everything inside of it so you can work on it.
And you don't have to do the -1.
You don't have to do -1 or anything like that. So yeah, this is totally the easier way, right?
If you want to do the less than or greater than thing, would you have to still do the get?
You don't have to do the get anymore. If you want to do that, branch like this, greater than, integer greater than integer, same thing. I'm going to type 50 here. And then this is just that right there. This guy is the same thing as doing a get at the current index. This guy's spitting out what you would normally use a get at the current index for. Okay. So what kind of practical applications of this are good? Well, a lot of things in Blueprint will give you an array of things back. For instance, if I go in here and you guys can follow along with this, just add a bunch of static mesh props into your scene, like a couch, and then like a chair, and like here's a lamp. Oops. Put a rock in here. Table. A couple pillars. You guys ever see the Harlem Shake videos?
Oh, yeah.
Okay, we're gonna do that. So I have a bunch of static meshes. And once I've selected all of them, because we're going to make these guys do the Harlem Shake, I'm going to make them movable instead of just static. So I selected all the static meshes I just placed, and I clicked the movable guy here. Otherwise, what we're about to do isn't going to work. Have you ever seen the Chrome plugin for the Harlem Shake? You can make any web page Harlem Shake. There's like a bookmark you can add.
How do you make some?
So go here, inspect element. There's actually a bookmark. I don't know why it's doing all this. There's a way you can do this with a bookmark.
Con los terroristas.
And do the Harlem Shake.
seen that before?
I
It's
put it on my wife's computer when she's not looking.
you can do. There's a bookmark you can add to do this.
Con los terroristas.
And do the Harlem Shake.
Okay, so that's the Harlem Shake. So did you guys make your static meshes movable as well? Because that's key, because they have to be movable to shake. Okay. So I want the F key when I press it to basically shake the things in the level. So I'm going to delete everything again because I seem to enjoy doing that, all the work that we've done. So after I've made all my static meshes movable, I'm going to go in here, I'm going to do a for each loop. You guys can follow along here. For each loop, one word. Okay, you guys have for each loop? Okay, so drag a wire backwards from the array. And it's going to give you any operation that returns you an array from Blueprint. And specifically, we're going to type get all actors of class, which will return you every actor in the world that matches a specific type. In this case, class is representing like static meshes, players, emitters, blueprints, triggers, whatever thing that you can think of, whatever category of object you can get. So in this case of class is going to be ours. I'm going to plug this in between the F key and the for each loop. So make sure your execution wires are hooked up like this, where they're in between the two. And then the actor class here is going to be static mesh. Static mesh actor, one word. Okay. So just for fun, let's just first start off with hiding and unhiding them when we hit the F key. We're going to toggle the visibility on these static meshes when we press the F key on all of them. Okay. So this is going to give me an array, and remember, this for each loop will run over every element in that array, no matter how many elements are there. So now what we can just do is call toggle visibility. Oh, sorry, it's easier if you drag the array element. So drag a wire off the array element and type toggle visibility there. Why does that not show it? Huh. Oh. Yeah, these guys should have a toggle visibility. I'm going to try right-clicking here and type toggle visibility. It should be able to plug in there. Right, can't do that. We're going to do this. Drag a wire and type visibility or set hidden. Sorry. I'm sorry, what's that? Set actor hidden in game, yeah. The reason why we couldn't toggle the visibility is because toggle visibility requires you to get a component out of that guy. And while we can get a component, this thing here is an actor. I'll show you guys how to set it up so you can toggle the visibility as well. But let's just see if we can hide all the static mesh actors when we press F. You have to make sure you check this checkbox to true, that they are hidden in game. Did that work for you guys?
Yeah, bring them back though.
Okay, so let's work on bringing them back. I'm going to show you guys two ways to do that again, because right now it's only ever bringing them, showing them, it's only ever hiding them once. And did you guys see that it actually hid more than just those? Does it hide the white cubes for you too?
I think it
anything that's a static mesh and movable, right? I think it might even hide the, no, it doesn't hide the bar. So if we want to hide and unhide them every time that we press the key, right now it's always hiding them, right? But we can make a variable that just toggles this, or we can use the actual toggle visibility function, because I think we want to actually toggle the visibility on these things as opposed to just setting them hidden. So how do we do this? We can do this two ways. Let's use a variable first, because right now it's always setting it to be hidden. So let's make a new variable that's a bool, and it's not an array. I'm going to call it should hide, and make sure it's a Boolean variable here. Compile your blueprint once and make sure the default value for this is set to true, and then plug this guy into your set actor hidden in game. Okay. Once you have a variable that controls it, play, and make sure they still get hidden when you press F. Does that work for you guys, Michael, John? Yeah. Okay, so now all we have to do, we have a variable that controls it. We're going to flip this variable back and forth. Every time we hit F, we're going to change this variable from true to false and back again, right? Every time you hit F, it's basically going to flip-flop the variable. So it's going to say, hey, if you're currently hiding it, go ahead and unhide all the actors. So what we need to do is we're just going to go ahead and grab set should hide, bring it into level, and make a setter here. I'm going to stick it in between the F key and the get all actors of class. And should hide here, this is going to be a little weird. We're actually going to use a branch here to control whether we should hide it or not. So I'm going to drag another wire that's a branch. And then we're going to set it again. We're basically going to have two sets. One that's going to set it to true and one that's going to set it to false, right on top of one another. Or plug them in together like that. It doesn't really matter the order here. And then you just have to drag should hide onto your branch condition here. It's kind of crazy. I'm going to explain this in just a minute. But so your branch should look like this. This is in between my F key and my get all actors. It's basically saying, hey, if I'm currently hiding it, go ahead and unhide, set it to so that they shouldn't hide. Otherwise, set it to true. Yep. And you get this behavior here. Notice they're hidden. Okay. So let's actually do the. Did you guys get this? Does it work that way for you? Yeah. Okay. Let's do the Harlem Shake. Delete the hidden stuff. Since we're not actually hiding it, I was just to show you guys how to hide and unhide this behavior. We're going to not do the hidden. Instead, what we're going to do is we're just going to rotate this guy randomly every time we hit F. So let's grab the loop body. We'll do set actor. On the array element, we'll do set actor rotation. On the loop body. Whoa, that is not what I wanted to do. Hang grab the array element, set actor rotation, like so. We'll just make a random rotation. And how do you make anything random? Well, the rotation takes a roll, pitch, and yaw. We can take each of those values and make it random. So take your actor rotation here. And we could just type in stuff here, but we're going to actually drag a wire backwards. We're going to make a rotator. And this rotator is going to consist of 3 float values. Each of these float values, we're just going to get a random number for each. So drag a wire from your float values here for your rotator, and type random. Get a random float in a range. And it's going to be between 0 and 360 for each. You're going to do this 3 times over for each yaw, pitch, roll. And that's it.
Random float in range.
Yep, that's what I use. And I did from 0 to 360.
Certainly looks like they're dancing.
Do the Harlem Shake.
Con los terroristas.
And do the Harlem Shake.
Con los terroristas. Con los terroristas.
Harlem Shake is awesome. I don't know why that became a thing, but it's awesome that it is. We can do the same thing. So when it hits G, we can reset the rotation back to what it was, right? So I can just quickly do right-click, do G, and when G is pressed, go over all actors of that same class and just set the actor rotation right here. So when I press G, it'll reset their rotations back to 0, 0, 0, which will reset everything so it faces. Right? So every time I hit G, it'll reset their position to be 0, 0, 0, no matter how much. So for each is super powerful, and we're going to be using it to grab, for Angry Birds, our version of Angry Birds, we're going to be using it to grab how many pigs we have to kill, as well as controlling like when we should transition to the next level, and how many birds we have left too. Okay. Questions on any of this? Okay. We're going to work on blueprint communication today too, because we need like the rocks to communicate with the bricks and the birds to communicate with you. Okay, so let's start with Angry Birds. Can you guys all open up your map for your levels that you made? And if you didn't make a map, then go ahead and make a new project. It doesn't really matter what project you make. I'm actually going to use the rolling project just because it has a ball material that's shiny that I can use for the Angry Birds. You can do this using a side scroller as well. I'm going to rip out all the stuff that's currently in there for the character anyway, so. Okay, so new rolling ball. What should our game be called? What am I actually firing? What's relevant right now in game media? It's like a meme that's going around right now. What's on the front page of the internet right now? Hidden bosses of Skyrim. That's kind of cool. Dragon found in Blackreach. Uses unrelenting force on the orb. Interesting. Dawnguard DLC.
I played that guy. The second one, Car Stack.
Yeah.
I don't remember the Reaper though.
Dawnguard DLC within a building in a soul cairn. You can only be summoned by gathering 3 Reaper gem fragments and placing them in the altar. Weird. Okay, that's not really relevant. Let's just go here. What's a game that came out recently? Order 1886 came out.
What's that one that everybody was all raving about? It's like almost like Halo, but not as good.
It's like Halo. Really?
Titanfall?
No, it's
Evolve? Evolve?
Oh, it was Evolve? Maybe?
Is it Call of Duty?
I don't think that's
Advanced Warfare?
No, the one that everybody and their brother was all like,
Destiny?
Destiny.
Destiny.
Everybody
Destiny.
was like super stoked about it, and everybody's like, fuck this game, it's stupid.
Yes, we're gonna make it a Destiny-based game. That's the COD piece. That's Master Chief's COD piece, right?
Is that what it is?
Have you seen that?
Yeah. Oh my god, it is.
Like that right there is the COD piece.
Sorry, Microsoft.
So we can launch the Traveler at people. Okay, so we'll just do something like
I
that.
never even played it. Is it as bad as everybody says?
No, it's actually a good game. I don't know why people are upset about it. It's all of our designers are actually playing it too. The raids in it are apparently quite good. Like they're well designed and fun to play and challenging.
I guess it's not a new Halo. That's why everybody hates it.
I'm gonna make this game called the Angry Fanboy, and that way we can poke some fun.
Nice.
Okay. So whenever I'm making a game, any kind of game, no matter how complicated that game is, I always try to break that game's features down into the smallest little bits of gameplay so that I can work on one little piece at a time, right? When you're making like a Lego model or you're building a regular model, you're not building the whole thing at the same time. You're building little pieces of it separately, and then once those pieces are done, they're a little bit bigger than they were. And then you take those pieces and you combine them with other pieces that you made earlier. And then eventually you'll get your model. But the first steps are always like you're working with like small bits, right? Have you ever, when's the last time you guys ever built like Lego?
Yesterday.
Yesterday, really? You follow these like instructions like this?
Not these instructions, no, but
I got some tips.
What did you buy?
I bought the Millennium Falcon.
Nice, I have that. I have the Millennium Falcon, my wife got it for me. It's really good. But here, right, so like when you're building like this mech, you don't start off with the mech. You build off like the legs first. And the legs are made up of very, very simple pieces, right? It's manageable chunks. This is how I think about game development. I don't think about trying to make this by making like this or this. I try to think about making this by starting from step 1, the smallest like foot. Like, oh, I can make a foot. A foot is just like 2 pieces together, right? Or like, I don't know why that thing is so low quality. Wow, these are like terrible.
Where can a man get a good Lego instruction around here?
Those are all terrible. You can't even like make out any of these things. All right, Google image search, come to my rescue. There used to be like, hey, only show me the big images.
Search tools right there, and then go to size.
Oh yeah, this is what I want.
I still use that a lot.
It failed me. Still.
This beach ball has like. There should be a resolution.
There we go.
There's not.
So like this lunar walker, right? Like step 1, put 3 pieces together. Okay, on step 2, add a couple more pieces, right? This is, I mean, it's kind of contrived, but it's actually what I think about. Like when I think about Angry Birds, what is like step 1 in Angry Birds in your mind, right? What is an example of one of the simplest parts of Angry Birds that you can make? Yeah, level is like one of the simplest parts. What's the next simplest part? How about throwing a ball? What's even simpler than that? How about just a ball flying through the air? No interaction, just level starts and ball flies through the air, right? We can just do that. Why don't we make the first thing be the ball launcher? Forget about it hitting anything. Let's just make something that actually can be interacted with. Let's make it so that when I click the button, it creates a ball and shoots it in a specific direction. I don't really care what direction it is or whether it flies far enough. I'm just going to click a button and a ball is created. And then what we can do is have that ball that's created fly, okay? So here's my here's the sample project that I guess it starts with.
Oh, wait. Can't even not see.
This guy here. Yeah, we're not actually going to use any part of this except for maybe the ramp. I like the ramp. I'm actually going to delete most of this stuff. Like, I don't need these cubes here. I don't need...
You need the shadows?
I'm going to rebuild lighting here to get rid of that. Get rid of these small cubes as well. I don't think I need any of these. Get rid of all these. Okay, here's my level. Let me just build lighting real quick to get rid of the shadows. Okay. I don't even want this ball. So before we even get to the part where I can click, how about we just take care of having a view of the level be the way that we want, right? Right now, the player is kind of controlled here, like so. And instead what I want to do is, I don't want this thing to be controlled with a ball or anything like that. The problem is, that is what currently is controlled, that is what is currently controlling the game. So we're going to get into our first foray of actually making a game now. And so there's a lot of parts to making a game, but really the keystone of making a game is this game mode blueprint that comes with any of the sample projects that you make. So if you look in your blueprints folder, you all will have a game mode blueprint. The game mode blueprint is kind of a special guy. He has some properties for specifying what type of dude is your player, what type of pawn is your player going to be represented as, what type of HUD do you show, and what kind of game state do you use, meaning what type of variables does your game care about. If you all open up your game mode, you should see this list, right? You guys all see this list?
It has two different ones. One's my game and one's new blueprint.
New blueprint is probably one that you made. It's yours is called my game in your case. Okay. If you double click on that, you should see this list show up. You guys all see these buttons over here by each list here. So the default pawn class is the important guy. This is the blueprint that is created when your level starts. Okay. For me, it's a ball. For you other guys, it might be like my character, right? We're gonna change it because we don't want like a 3D guy running around. If you think back, Angry Birds doesn't have any of that, right? Angry Birds. What is your player actually doing in Angry Birds?
Your player is pretty much a slingshot.
It's not even a slingshot because I can move the camera around, right? Like the player is pretty much just a mouse cursor. I don't need to watch a single My player right now, it's the camera, right? It's all the player really is. So we're going to make that first. We're going to make a camera that can move left and right, which means we need to replace what is spawned here with, instead of the ball or my character, we're going to replace it with our own. So click the plus button. This is going to be a new guy. We're going to call this, put it in the blueprint folder. This is going to be the, for me, it's going to be the angry fanboy pawn. So you can make one here as well. Like this plus button will make you a pawn, or you can always make one here through new class blueprint. You can make a pawn this way too. there's a kind of an issue here, which I think will be okay. When you guys made your character, you should have been able to see this thing here, which in the top right you should see pawn in your blueprint that you made. We're going to change it. We need to change it from a pawn actually to be a character, because I want the A and D keys to move him left and right in the screen. So our guy is actually going to be basically like an invisible character that just has a camera attached to it.
Is that one guy from Mario?
Which guy? Lackady. Yeah, it's basically that guy, but without a mesh or anything like that. He's basically holding a camera for us and nothing else, and you can move him left and right. Without getting into too much of the details, a pawn by himself doesn't allow you to move the character with the keys. While a character, which is a type of pawn, lets you do that. So we're going to make a character instead. So in order to do that, go to your blueprint properties, click on that guy, and you'll see details in the lower left. Where it says parent class here, I want you to change it to be just character. Okay? And compile. And what you should see now is you should see a capsule here in your blueprint, which represents Lackady, or like the invisible camera guy. Did you guys all reparent this? Did you guys reparent your type? You click on blueprint props. This should say character. You guys all see a capsule here? Yeah? Michael, you got it too? Do you see a capsule? Go to blueprint props, and then parent class here. This is the blueprint class that you made to replace your pawn. Did you make him from, yeah, here, let me take a look. Yes, that's right. Then go to blueprint props. And then should have the pawn. Cool. You see a capsule there? Which is good. Okay. Now if I play, you guys should see a view which is only from facing the direction of your spawn point. You can't move the character or anything like that. Okay? You guys see that? Like you should see something that you cannot move. That means that it's working correctly and you can't move. You fall? Do you see this?
I'm looking the wrong way.
Okay, so the direction that you're facing is important. That is dictated by your spawn point. So if you go into your level and find the player start actor, the direction that the red arrow is facing is the spawn direction. So make sure he's spawned towards your level. And put him at a distance that you feel like is a good distance for your game. Yeah, it'll fall.
Do I need to adjust my base then?
Just your player start. You just need to spin him
Do I
around.
need to make this bigger so that?
Yes. Yeah.
Or
Do you want?
hold this back further?
We actually, you know what? Let's make it so it doesn't fall, because that way it'll make it easier for you. It's really easy to change that too. So if you go to your blueprint for your pawn. Yeah, you don't have, but like you don't want to have to put a floor every time. No. We're going to make him flying by default. So go to character movement here. Click on the character movement component. I want you to scroll down to the default land movement mode. Where it says walking, change that to flying. There's two. There's a water movement mode and land movement mode. So change it to flying. Now you can put your spawn point wherever you want, and the guy will not fall. Okay. So you can do that too. Cool. So that's our first step. We have a dude that's in the game that is not like a blue guy running around. Cool. We have first step of Angry Birds. We have like a static camera. So let's make it so we can move this camera left and right. Okay. We're going to actually script that in the blueprint. So if you go to your player now, go to your pawn, and go to the blueprint graph, it should be empty. Let's just make it so that when we press right or left, that he moves right or left. Okay? So I want to take a little bit of time to explain some of the things about game development that are not really fun but are important to know. A lot of players don't necessarily use the keyboard and mouse to play your game. In fact, you might be playing this game on an Android phone or an iPhone. What is the equivalent of moving left and right on Android phones? Or what is the equivalent of moving left and right using a 360 controller? It's a joystick, right? So you can use, in our game, I want to be able to use a joystick to move left and right, or A and D to move left and right, or the arrow keys to move left and right. Okay? Those three different types of input I want to be able to support. If you want to be a good game developer and help out, you typically should be binding your keys to something that combines them all to say, hey, this player wants to move right. And that collection of keys is defined in Unreal. So if you go up into Edit and go to Project Settings, go to the Input section here. So this guy here is one of the only properties that you'll edit a lot under your project settings. And I want you to just open up the Axis Mappings array and expand Move Right. You guys should all have a Move Right and a Move Left under Axis Mappings, under Input on the left. You guys see that?
I have a move right.
And a move forward and move right, right?
I just have move right.
I just have move right too.
Oh, because you guys use a 2D one, right? Yeah. That's fine. Does your move right look something like this, though, right? Where you have a D and an A and gamepad stick and a right and a left and gamepad. Okay, so this is what I was talking about. Moving right in our case is, I'm going to hit D, okay? The D key here corresponds to moving right with a scale of 1. A moves me right with a scale of -1, which is actually moving it left, right? Okay, it's all under the same thing, moving right. But notice I also see gamepad left stick right and left stick left. This is the analog stick. This is the joystick. But notice at the bottom I also see gamepad left X, okay? This is also the D-pad. This is the D-pad for moving in a direction. And then I have the right and left arrow keys here too. So there are a bunch of different ways that I can move right or left in our game. And all of these correspond to a single event that I can use in my blueprint so that no matter what you want to use, they're all going through the same system, okay? Does it make sense? So what we're going to do is we're going to use this move right to move our camera. So I want you to right-click in your blueprint and just type move right. Anything that you add, you can add new axes there. You can have a move up, you can have a move down, you can have whatever you want. Will get converted into an axis event and an axis value. So we want the axis event here. This thing will fire every time that you, this fires every frame actually, and it tells you how much they're currently moving right or left. That's the number here. Let me print this out to the string. Let me just show you what this actually is doing here. I wish I would have brought my 360 controller. I'm just going to plug this into a print string, the input axis move right. I'm going to press play. What you'll see is that it's always printing out. I'm going to press right on the arrow key. You get 1. I'm going to push left on the arrow key. Okay. D and A do the same thing. Okay. If I flip back and forth, you can see how it does that. If I, yeah, D, that's the value that I get, and A, that's the value that I get. That's the scale. That's what this thing is printing out right here. That's the axis value. If I had a 360 controller with me, it would be, depending on how hard I press the analog stick, it would be between 0 and 1, okay? Or 0 and -1. What's that? Yeah, right. It's either on or off, right? Yeah, that's why driving games with a keyboard is so hard. If you guys ever try to play like a racing game, Yeah, it's full on or full off. There's no way. Now, some games try to like have a sense of acceleration where maybe I press D and it doesn't go to 1 like right away. It like ramps up to 1, but it's still faking it. Like with a controller is where you get the actual precision for moving it around. For our game, it doesn't really matter. We're just, now that you know that this thing goes between -1 to 1, we can use that. And all I need to do is I'm going to right click. Actually, I might be able to do this. I'm going to drag a wire and type add movement input off the input axis move right. So add movement input will convert a number that I type in and then move me along this world direction. Okay, this world direction is in world space. Yeah, it's going to be based on what your level is set up. In this case, it is Y. Yeah, so I want to move Y. So the world direction is going to be 1 in Y. And the scale value is literally just the axis value that I plug in there. That's it. Does that make sense why that's Y1? Because that's where, if I move this guy, look at his property on the right, the thing that's changing is his Y. I want to change that. Okay, so I had movement input, put the scale value in, press play, and I can use A and D to move left and right.
For some reason, when I push D, mine goes left.
Mine did the same thing. Your level was set up reverse, so you spun it around and now you're going backwards.
If that is the case, you can just do -1 here.
Oh, yeah.
Wouldn't it be easier to change it PS to, oh, I guess only movement.
Yeah, you can do it a lot of different ways. You can also multiply this by -1 before you plug it in here, if you want.
And that movement's not even really all that important unless you just want to work anyways.
Yeah.
Because in Angry Birds, you're not, it's not like
Yeah, I mean, they do have it. Like, you can move left and right because some of the levels are kind of bigger, right?
yeah,
So,
but it's not like super important.
I mean, it is kind of important because, like, some of the levels you can't see at all, any of the things. You can zoom out for a lot of levels, right? But,
What if you wanted to zoom in?
yeah. In fact, what they do, I think, is that they actually follow the bird, right? So if I'm looking here and I'm zoomed in, notice the camera actually follows the bird, okay? We're not going to worry about following the bird or anything like that for now. We're just going to have the camera move. But already, if you can imagine, Angry Birds like-esque, right? You can kind of move the camera left and right.
And it drifts when you let go, too.
Yeah. If you want it to move faster or slower or change the properties, you have to go into the defaults here. And scroll down to where it says character movement. And since our dude is flying, you have to adjust the max fly speed here. You can make him fly faster. And if you want him to slow down faster, you can increase the air friction. Where is the friction? There's the ground friction, deceleration, braking, deceleration, flying. I'm sorry, what's that?
You have to have more drag versus
Yeah, if you want to slow down faster, then yeah, you want the braking, deceleration, flying, which will be, you can increase that value. So these are the values where you tune to be able to make your guy fly faster and come to a stop faster. And if you want him really just to be, you can just crank this thing up, like 5,000. And you can increase the acceleration here as well to make him instantly accelerate, and then deceleration can be the same as the acceleration.
Is 100 just not very much? Because it didn't.
100 is not a lot. This is how many centimeters per second it changes. Okay,
It's braking, deceleration, falling, right? So we're supposed to be.
flying.
Oh, no wonder. Well, that's why it didn't work.
If you want, it's just max acceleration. If you want to accelerate faster, if you want to go at a higher top speed, you have to change the max fly speed. Yeah. Yeah. This is when falling, if the lateral velocity magnitude is less than this value, air control is multiplied by the air control. So this is basically like if you're not moving a lot, if you're not moving very fast compared to this value, then you're allowed to have, you have more air control in this case, or a multiple of air control based on this number. So it's kind of like how you ever notice when you're driving your car on the freeway, like small movements on the freeway translate to larger, like it's a little less sensitive when you're moving at higher speeds. That's intentional because you don't want like small movements on a freeway to turn you the same as if you're moving still, right? So it's basically a scalar for that. Okay, do you guys all have this, like a camera that's left and right? So how about we make a button? Why don't we make the left mouse button, when we press it, spawn a physics ball that just drops. Just spawns at a specific point in the level and then just drops, okay? That's going to be the first step to getting this behavior of the Angry Bird where we click and it creates a ball that launches. So we're going to make a blueprint now. We're going to make a blueprint that's going to be eventually our slingshot launcher thing, and then we'll convert it into an actual mesh. But for now, I'm just going to make our slingshot launcher just spawn a regular physics ball.
So spawn actor.
Yeah, so we're going to make a new class blueprint first. And this new class blueprint is going to be an actor. I'm going to name it BP underscore angry fan launcher. Angry fanboy launcher. And just like all of my other blueprints, I'm going to add a scene to this. Just because I want I want to be able to move and scale things that are attached to it. And let's add, I kind of want to see where it is in the level. So let's add I'm going to add two things. I'm going to add a billboard. This is just an icon, essentially. And then I'm also going to add a second scene to this, which I'm going to call the spawn point. Yeah, I just added a second scene called spawn point. And while I'm here, I'm going to parent my little billboard guy to my spawn point, so that wherever I move my spawn point, it moves the billboard too.
So you spawn the icon to. Okay.
Yeah, I just drag the icon on top of my spawn point scene. So you should have two total scenes, one that's called the root and one that's a spawn point. Because we're going to move this spawn point, we're basically going to make this thing mimic the slingshot. If you can imagine, our spawn point is going to basically create a bird at that point of the slingshot. That's what it's going to represent. Like right there, that's where our spawn point is going to be. And depending on how far we drag, it's going to create a new physics body there. Okay, so let's place one of these things in a level now. And I'm going to place it kind of in the level where it should be. Create a Angry Fanboy launcher here. Don't worry about the orientation for now. We're going to fix that up in just a second. I'm going to kind of just place it there for now. Okay. Now we need something to actually spawn. We need an actual ball. We're going to make a ball from scratch. You guys all place this? Your little.
I placed it, but I don't see it.
Do you have a billboard attached to it?
Yeah.
Wait.
Oh no, I got it.
You got it? Okay. The reason why we go like step by step is to make sure that you make sure each one of these pieces work separately. That way, as you move on, if something doesn't work, you know what to spend your time on. Okay, so let's make yet another blueprint, another active blueprint. This time it's going to be the ball. I'm going to call mine the Angry Fanboy, because that's what we're actually launching. Yep, I'm going to add a scene to this thing. Call it the root. And I'm going to add a static mesh to this guy. And it's going to be the actual ball. And pick a round like a sphere. This thing happens to have a nice ball, shiny ball. But you can pick any of the sphere mesh. You can use this guy too. That's fine. The important bit is that you simulate physics on whatever you add. And you can test that by, if you click simulation, he should fall. Right? You guys all have a ball that simulates with physics? Okay. All right, so that's what this guy we're going to spawn. Yeah, you're okay, Michael? Okay. So we're going to make the left mouse button spawn a ball every time we click on it. Okay, that's going to be the first step. Then we'll have it shoot. Then we'll have it increase in power the longer we hold it down, et cetera, et cetera. Okay. So in our Fanboy launcher, in the whatever ball launcher you have, I'm going to go to the default properties first, and I'm going to set the auto receive input to be player 0, because this thing is going to listen for all of our input all the time, and I want to always listen to player 0. Player 0? Okay. Now go to your graph for your launcher, and we're going to have the left mouse button spawn a guy. Now remember what I just said about the different ways you can spawn one. Remember I said left mouse button could spawn one? Or maybe you're playing with a 360 controller and you want right trigger and A, and like you're on the phone, you want the tap to spawn one. Instead of just tying into left mouse button directly, I'm going to show you guys how to set up an action mapping so that you can use any of those inputs that you want.
Would you click on function?
Go to edit and then project settings. This is the same place we were just at. And go to input. And go expand action mappings. You might have one for jump already. If you look at jump, notice it actually has spacebar and like touch 1. And we're going to add a new action mapping here by clicking the little plus button next to the action mappings. I'm going to call this one fire. An action mapping gives you both a pressed and a released event. So it tells you when they start pushing it and also when they let go. In this case, I want this one to be on the mouse. I want when the left mouse button goes down. And for fun, we'll also do the space bar as well. I'm actually going to delete my jump action mapping. And you can add things like on the gamepad, face button bottom. Sure, you can add, not that I have a gamepad here, but you could think like right trigger as well, could also be that, right? All these things could in theory be linked to firing, okay? Add whatever you want to this, just remember what you did, what you ended up adding. And remember what you called it too. Once you've added that, now you can right click in your launcher and you can type fire. And this is your own custom event mapping that has a pressed and a released event. So you know whenever they press the left mouse button and release it, or the space bar and they release it, or the joystick, like the right trigger, all those things route to the same event, okay? In this case, when I press this, I want to create a ball. And so, yeah, we're going to need to do a spawn actor. So we're going to drag a wire off of this. We're going to spawn an actor from class, okay? And the class that we're going to spawn is our ball that we made. In my case, mine's called the BP Angry Fanboy. Yours might be called something different. This is the blueprint for whatever you just made for that has the physics ball. So this is the type of class that you're actually creating here. And we need to tell it where it's going to spawn, including the direction, the rotation, and the scale of how big to spawn this thing. This spawn transform, we want to spawn at the spawn point that we created earlier. So that's what we're going to do. I'm going to drag the spawn point in here from the left. I'm going to do a get. And I'm going to drag a wire from him and type transform. And what you want is the world transform. You want to get the world transform off of your spawn point and then plug that into your spawn actor. This means that whatever direction your spawn point is facing and however much it's scaled, it will in turn scale whatever you spawn and rotate it that way too. Okay. Now if you play and get your camera in view, yeah, they do stack at first, and then do they eventually roll towards you if you spawn enough? You guys all have this? If you spawn enough of them, they'll eventually come at you, because we're about to fix that.
Kind of compress for a second and then
they just start eating like this.
I think mine roll away because I have a little bit of a ramp, actually. Like if you see mine also stack like this. Oh, yeah, but notice mine are actually slightly on a ramp, which eventually introduces some entropy. So eventually they'll actually come towards me. But you guys all have it spawning, right? How about you, Michael? The spawn point is a component on the launcher. It's just it's just a scene. The next part is to apply some force to this thing so it actually flies. Actually, let's while we're here, let's constrain the physics. Even though you guys don't have this problem, you might, where it'll fly towards the camera. It does happen. It just won't happen unless you have something other than, like if you have a ramp or something like that, it'll happen more regularly. So let's constrain that. You got it spawning, Michael, yet? Come take a look. You want to add a spawn point to your launcher? You're in the ball. All this behavior goes in the launcher because that's what's actually going to be firing. I would get rid of that stuff in the ball first, otherwise you're going to have some really weird information. You should really try the dragging wires off. The context-sensitive nature is going to help you a lot. It'll save you time because then you don't have to like connect them afterwards. Oh, okay, yeah, and then put the spawn point in the wall. And then carry a wire from him to get world transform. And then plug that into the spawn transform. That's it. Try that out. Are you receiving closest? Did you change your launcher to receive and from the player zone?
for it. It's not good in the book, so.
Okay, so let's constrain the physics. We'll do a couple more things. I'll give you guys a break too, so we can get some time. It'll be a shorter break today.
Question really quick.
Yeah.
Next to the play button at the top,
Hmm?
like a drop down,
Mhm.
BP Angry Fanboy Launcher on the side of that.
Oh, this one?
Mine has two. I have BP Launcher,
Mhm.
BP Launcher 2, and right now it's set to BP Launcher 2.
This thing will find instances that are placed in the level. So in my case, do you have two guys placed in a level by chance?
I might. I do.
Yeah, this allows you to debug specific instances of that blueprint in your level.
Okay.
Okay, so let's constrain the balls so that they don't fly towards the camera. This is the same thing you're going to have to do for your bricks too, because your bricks and the pigs, or the equivalent of the pigs, you want them constrained to be along this axis here, along Y and Z, right? Only along that. You don't really want them to move towards X at all, right? You want them to be basically only on the green and blue axis, okay? So go to your ball and go to the default properties. I'm sorry, not the default properties. Go to the properties of your ball, the mesh that actually has the physics on it, and scroll down under the physics category where it says locked axis. And in this case here, we're going to lock the movement so that the x-axis is not moved. So if you pick X here, this will mean that, hey, when it's simulating, only simulate, lock the axis so that X is not moving at all. Only Y and Z are allowed to move. And so now when I spawn these balls, none of them will ever come towards the camera. It's almost as if they're all stacked in a giant like pachinko machine or in a Connect 4.
Pretty sneaky, Dad.
Okay. This is important for like making a 2D style game that is 3D, right? So you want to lock axis so that it doesn't actually move at all. No matter how much I do this, they won't move, okay? So let's actually shoot these guys out, okay? I want to shoot them out so that they shoot in the direction that this thing is aiming at. So first, let's just see if we can move this thing at all. So let's, right after it's been spawned, I just want to shoot it out in some direction. I don't really care what direction it is. So go to your spawn actor, drag a wire from here, and what we're going to do is we're going to type velocity. And what we want to do is we want to set the physics linear velocity. The difference, you guys know the difference between linear and angular velocity? Like angular is like spinning the ball, while linear is like moving the ball, like translating it.
So it's gonna launch straight out.
Yeah, we want the set physics linear velocity. Okay. Now we get to pick. What's the velocity going to be? Well, let's just type in some values. Let's type in like 10,000 for Y and 3,000 for Z. Let's just see what happens there. I don't care. Don't try to fix the direction. This is not actually how we're going to be spawning it. I just want to prove that you guys can move the ball, right?
Whoa.
You guys all getting it?
Fast.
You guys all getting it spawning? It's like a sprinkler. I tuned it down to 3,000 and 1,000. So I guess I do kind of want to know what the max distance is, because in Angry Birds, like if I'm pulled back all the way on a bird, like at a 45-degree angle, how far does it go? It kind of doesn't really go that far even. Like I would say like that's probably the furthest that it can go, maybe a little bit past the screen. So it doesn't have to be crazy, right? It doesn't have to be a large amount. So I'm going to just make this thing, it seems like 3,000 and 1,500 might be a good, it seems like good. Like if the player was basically fully charged, and I actually want to constrain this so that he cannot shoot outside the wall. Just barely. Okay. So instead of hard coding value here, we eventually want this thing to go further depending on how hard they pull back. And we want to kind of aim in the direction that they want. Right now, if I want to aim this higher or lower, I can't. But how do I control whether this thing goes up higher or lower? I adjust the Z height here. There's a better way to do this though. What we can do is we can go back to our launcher and let's just stick an arrow onto our spawn point here. I'm going to go back and add another component. And I'm going to parent it to the spawn point. And the reason I want to do this is that now if I rotate the spawn point, you guys should all do this too. You guys need to add arrows to your spawn point. This will help you. Go to your launcher and add an arrow to your spawn point and parent it to your spawn point too. And notice that when I rotate my spawn point, the arrow moves as well.
And the arrow won't be invisible, will it?
It will be visible in game, yes. You can see it in game. Although in my case, it's parented to something that you cannot. So what I can do here, actually no, in this case it is hidden in game. You can make it visible in game if you want to. In our case, we do want it to be visible in game. So once you make your arrow, click on your arrow and then uncheck the hidden game checkbox. So you can actually see, make it large enough too that you can actually make it out. I'm actually going to crank up the size of the arrow to like be 20. Maybe that's a little big. Yeah, that's why we have the arrow, because that arrow is going to dictate where the direction is that we're going to spawn our ball.
So would I just turn that in the right direction in my game?
In your game, yes. You're going to spin that around in your game to be facing the right direction. So now that you have an arrow attached, you should be able to rotate your guy. Looks something like that. You guys all have an arrow that's in there, Michael? You good? Is it parented to the spawn point too? Okay.
My arrow's in the right direction, but I'm still shooting at the eye.
Yeah, that's fine. That's the next thing we're going to do. Because what we're going to do is first we're going to see how when I spin the spawn point, as I adjust the pitch of the spawn point, notice the arrow moves too. So what we can do is we can just spawn a ball and then we can shoot it along the arrow. And then all we have to do is spin the spawn point around and then our ball will fire in that direction too. Okay, one step at a time. First step, let's just have it spawn in the direction of the arrow. So go to your graph. This is our velocity right now. Yeah. Sorry, I'm just reading some of my notes here. Okay. So this guy here, the direction that he is supposed to shoot is going to be based off our spawn point. So let's drag our spawn point in here. We are going to get the forward vector from the spawn point. Now forward is the direction that he's facing forward. You can also get the right and up, but get the forward vector. And this will return you the vector of what direction he's facing. Now, if I were naive, I could plug this in here. But the problem is that that's only going to be a very, very, very small amount of actual velocity. This velocity is huge. It's 2800 and 1400 in z. This number here is super tiny. It's a normalized vector. It's value from 0 to 1. So what we need to do is we need to scale this guy up to be big enough so that it matches what our previous velocity was. So what I'm going to do is I'm going to drag this guy off from the get forward vector. I'm just going to multiply it by a float, which will let me scale it by some number here. I'm going to scale it by 4500. And then I'm going to plug it into here. Okay. And you should see when you spawn it now, they actually follow the arrow. And to prove that it works, what you can do is you can spin your guy up in the air. If you go ahead and rotate this guy so he aims up in the level, and you shoot, they'll also shoot in the direction of the arrow.
So vector times a float?
Vector times a float, yeah. That scales the vector. That multiplies each component of the vector by that float and scales it up. You guys have, it's all spawning along the direction of the arrow. Prove that it does that. Can you rotate the guy, the launcher, in the level and make sure that he does this kind of thing? Okay. After you've proven that that works, I'm actually going to have you guys make sure he's actually facing forward. We're not actually going to be rotating the actor to spin this thing because this actor is going to have like a mesh attached to it. So we don't want to spin the whole mesh. We just want to rotate the arrow. But now we have this behavior. We have like the first part of Angry Birds. Do you guys want to take a break now, or you want to keep going? Anyone want to take a break, that is? You want to take a break? All right. Let's take like a 20-minute break. And then when all three of us are back, then we'll just continue the lecture. I think this is a good place to stop.
I kind of wanted to sit here and sort everything.
Yeah.
It's pretty satisfying. I like it.
Simple, right? Like, how long did that take? Maybe an hour? An hour and a half?
Yeah,
Okay.
I don't even want to have rules. I just